What if we could see spacetime? Imagine a world where spacetime wasn't invisible, a concept that we can only describe through equations, but a vibrant, ever-changing visual tapestry. What if we could visualize spacetime, the actual fabric of the universe? What mysteries would unfold if we could see it all? How would it make our understanding of reality and everything else change? Nature of spacetime. Such is the fabric of the universe. Spacetime, a four-dimensional sheet made from combining space's three dimensions with the fourth dimension of time. In a way that's quite dynamic and reactive, it bends and curves under mass and energy. Think of it like a trampoline. Place a heavy ball on it, and the surface bends. That's how spacetime works. Objects like planets, stars, and black holes distort spacetime, creating what we perceive as gravity. But because spacetime is invisible, we rely on tools like telescopes and math to understand it. What if we could actually see this bending, rippling, and flowing? The cosmic dance, stars and planets. If spacetime were visible, then night sky would be a fabulous, glimmering spectacle. The stars and planets would not just twinkle. They would leave glowing tracks and distortions in spacetime, like waves. Planets orbiting their star would seem as though they were sliding across sheets of invisible whirlpools, tracing beautiful, curvaceous paths. Massive stars would imprint deep grooves in spacetime, and black holes would look like dark, swirling whirlpools with light spiraling inward, caught in their gravitational grip. Just observing the universe would be an extraordinary ballet of light and curvature. Ripples in spacetime, gravitational waves. Perhaps the most exciting modern scientific discovery is that spacetime ripples and the gravitational waves made by cataclysmic events, such as colliding black holes or neutron stars, cause these ripples. So far, we have only detected this wave with extremely sensitive instrumentation, such as LIGO, measuring the tiny deformations of spacetime caused by gravitational waves. But if we could look at spacetime, we would see these waves like cosmic tsunamis rolling across the universe, stretching and squeezing anything that came in their path. Imagine standing on Earth watching these waves pass over it, distorting stars and galaxies like ripples in a pond. The beauty of this view has me feeling a little giddy and humbled, seeing the power of this universe. The view of everyday life. Spacetime isn't just out there in the cosmos, it's everywhere, even here on Earth. If we could see spacetime, everyday life would be transformed. You'd see the ground beneath your feet slightly bending under your weight, or the space around your car warping as you accelerate. GPS satellites, which rely on relativity, would become visual marvels. You'd see their clocks ticking at different rates compared to clocks on Earth, due to the curvature of spacetime caused by Earth's gravity. Time dilation, one of Einstein's most famous predictions, would no longer be an abstract concept. It would be visible. Black holes, the ultimate spectacle. Black holes would steal the show. Such regions of space where gravity is so intense that not even light can escape would look like cosmic whirlpools. Surrounding them would be the event horizon, a glowing boundary where matter spirals into oblivion. Around spinning black holes, spacetime itself twists and swirls in a phenomenon called frame dragging. Seeing this would feel like peering into the very edge of reality, where the laws of physics break down and time seems to stop. Time as a visible dimension. Perhaps the most astounding part of seeing spacetime is to see time itself.
Time is invisible, an unwavering flow we measure using clocks. If time were suddenly visible, you might see an object with a trail behind it, representing all of its past movements. There could be very dim outlines ahead of it, hinting at possible futures. In a way, you would view life as a film roll in which every passing moment creates a scar on the texture of reality. This would basically change everything we perceive as cause and effect, free will, and even mortality. Impact on science and technology. If we could see space-time, science and technology would leap forward. No abstract model or simulation would be required to study the universe because we could just see it. We could travel space more easily since we could see distortions due to massive objects and navigate according to them to get efficient paths. Understanding space-time at this level might even unlock the secrets of faster-than-light travel. Concepts like wormholes, tunnels through space-time, could become more than theoretical as we'd finally see and study their structure. Human perspective, awe and humility. Seeing space-time would certainly redefine the worldview of humanity. We would never be able to forget how interrelated everything is. Every step we take, every star we view, every second that goes by would be linked to this hidden yet observed tapestry of all that exists. It would foster a deep sense of humility. We'd realize that we're not just living in the universe, we're part of it. Our actions, no matter how small, contribute to the ongoing distortion and ripple of space-time. Conclusion: a new way of seeing. If we could see space-time, it would not only change how we understand physics, but also how we see ourselves. The universe would no longer be a cold, empty void, but a living, breathing entity constantly in motion. It's an interesting thought experiment that reminds us of the beauty and mystery of the cosmos. And while we may never see space-time with our eyes, it is through imagination and scientific discovery that we can get close to understanding this invisible dimension of reality. Next time you gaze at the stars, recall that you're looking into a universe that is not an object in any classical sense, but is a flowing, rippling, bending fabric. And you are part of that fabulous story.